You use ChatGPT, Claude, or Gemini every day. But if I handed you a whiteboard and said, explain how it actually works, could you do it? Most people can't. Here's the surprising truth, a large language model is not thinking. It's doing the world's most sophisticated autocomplete. Once you understand the 4 things that make that work, you'll never look at AI the same way again. Every conversation starts by breaking your words into pieces called tokens. The cat sat on the mat, the model doesn't see 6 words. It sees tokens, the cat sat on the mat, period. A token is roughly 4 characters. Think Lego bricks, some are whole words, others are syllables. Here's the mind-bending part, the model has never seen a letter. It only knows numbers. Token 464, token 3797, token 9573. Then each number becomes a vector, thousands of floating point values in high-dimensional space. An LLM is pure math. Everything flowing through a massive equation. Non-English languages use more tokens for the same meaning. Hindi and Japanese can burn 4 times the tokens. That's why non-English API calls cost more. How does a pile of numbers learn to write like a human? 2 phases. Phase 1, pre-training. The model reads roughly 13 trillion tokens, every book, website, paper, and Reddit thread. It would take you 25,000 years. The model does it in months. The training task is brutally simple, predict the next word. The capital of France is, guess, Paris, get rewarded. Guess, Rome, get penalized. Do this trillions of times. It learns grammar, facts, and reasoning as a side effect of the prediction game. Phase 2, reinforcement learning from human feedback. Humans rank AI responses from best to worst. The model learns to prefer answers humans like. This turns a text completion engine into ChatGPT. But it has a dark side, the model now optimizes for human preference, not factual accuracy. This changed everything, attention. Here's the problem. By word 5,000 of a document, how does the model remember word 3? Old models read left to right, keeping a running summary. Summaries lose detail. Attention solves this differently, every word looks at every other word simultaneously. Take the sentence, the trophy doesn't fit in a suitcase because it is too big. What does it refer to? Trophy or suitcase? Attention computes a relevant score between it and every other word. Trophy gets the highest score. The model figures out that it means trophy. GPT 5.5 and Claude Opus 4.8 both handle 1 million token context windows, entire book series in memory at once. But there's no memory between conversations. Every new message, the model rereads everything from scratch. You type a message and words appear instantly. How? The model generates 1 token at a time, autoregressively. It can't skip ahead. But inside each step, thousands of GPU cores work in parallel, billions of matrix multiplications, all at once. GPUs were literally designed for this. At 50 to over 200 tokens per second, about 150 English words appear in the time it takes to blink. Why so fast? Because at inference time, the model isn't learning. It's just doing math. Forward pass only, no backpropagation. GPT 5.5 output costs $10 per million tokens. Claude Opus 4.8 is $25. Why does AI confidently lie? Remember, the model's one job is to predict the next plausible token. Not the correct token. The plausible token. Ask, what's the capital of France? Paris gets 95% probability. Easy. But ask, what did John Smith say at the 2019 Widget Conference? John Smith might not exist. The conference might not exist. But the pattern exists everywhere in training data. The model generates the most statistically likely completion. It invents. And, I don't know, gets 3% at best. It almost never wins. This isn't a bug. It's the fundamental nature of the system. An LLM is a probability distribution, not a database. When the distribution is sharp, the output is accurate. When it's flat, the model fills the gap with whatever sounds right. Retrieval augmented generation fixes this by grounding answers in actual documents. Here's what to remember. An LLM is not a brain. Not conscious. It's a mathematical function predicting the next token, trained on so much text its predictions look like thinking. When you understand this, everything makes sense. Why it writes poetry but can't count R's in strawberry. Why it explains concepts brilliantly but fabricates citations. Why longer conversations degrade. Why non-English costs more. The magic isn't that LLMs think like us. It's that next token prediction at scale produces outputs so useful they feel like thinking. If this changed how you see AI, subscribe. Next episode, we build a miniature LLM from scratch.